Let's walk you through this. Which statement best explains the first ionization energy of sulfur being lower than that of phosphorus? So first, ionization energy is the energy it takes to remove an electron from an atom. And because sulfur is lower than that of phosphorus, we're saying it takes less energy to remove an electron from sulfur, so the electron is less attracted or more repelled by the sulfur. So the question here is asking why that is the case. So let's go through each statement one by one. For A, sulfur has more protons than phosphorus. So for this, we can go back to the periodic table and have a look. Here, we can see that sulfur does indeed have more protons than phosphorus because it has a larger atomic number, and atomic numbers essentially tell us the number of protons there are in an atom. However, because it has more protons, it should have a higher nuclear charge, and so by that sense, sulfur would theoretically have a higher first ionization energy because there's a stronger sense of attraction between the nucleus due to more protons and the electrons. So even though the statement is true, it does not answer the original question. For B, phosphorus does not have paired electrons in the outer p sublevel. So that is, again, another correct statement. So we can see here that for phosphorus, it actually has 3 electrons in the outer orbital, and that you can see based on counting from the periodic table. Whereas for sulfur, it has 3p4. And what that means is that if we draw out the energy level orbitals, which I hope you've seen the box diagrams, for phosphorus, it'll look something like this, whereas for sulfur, it would look something like this, based on Hund's law and the way that we draw orbitals. So B is a potential correct answer because what we do know about paired electrons, which is the case here for sulfur, it is that they would repel each other more than unpaired electrons for phosphorus. So that means that because they're more easily repelled in sulfur, they would have a lower ionization energy because it's easier to remove the electron. So B is a potential answer. As for C, sulfur has an unpaired electron in the outer p sublevel. So again, that is another correct statement, as we can see here that sulfur has actually 2 unpaired electrons. However, that is also the case for phosphorus, as you can see that where it has 3 unpaired electrons in the outer p sublevel. So even though it is a correct statement, it doesn't answer the question of why sulfur has a lower ionization energy. Finally, phosphorus is more reactive than sulfur. So this is just simply an incorrect statement, and we can know this because if the first ionization energy of phosphorus is higher than sulfur, then it's harder to remove an electron, and so it is harder for the phosphorus to react. Because at the righter end of the periodic table, for those elements to react, they have to lose an electron to form an ionic bond with the elements on the far left of the periodic table. And therefore, the answer to this question is B.